We want to look at one more example of half-life, but the reason I've chosen this one is it requires techniques that we're not actually permitted to ask you in Physics 30, but it's still good to know, especially if you do any more physics study a little bit later, then this is something that you will have to deal with and will have to know. So we have tungsten 181. It has a half-life of 121.2 days. So how long will it take for 95% of that sample to decay? Now, 95% decay is telling us we have 5% remaining. So what this actually means is that the ratio of what's left to what we started with is going to be 5% or 0.05. Because whenever we're doing calculations, we want percentages to be in decimal. So we have this n equals n0 to the 1/2 n. Or I could say that n over n0 is equal to the 1/2 n. And what I have here is I know that I have 0.05 equals 1/2 to the n. Now, to get the time, we're going to need to know how many half-lives occurred first. And that's the tricky thing. In math, if your unknown was in the base, easy. You took the 1 over nth root. In this case, you took the nth root, or you raised to the 1 over n power. When your unknown's in the exponent, we have to get that down. This is where we start to do the logarithm stuff. So to refresh, the log, and I'm going to use log base 10, the log of a to the b is the same thing as b times log of a. So what we're going to do is we're going to take the log of both sides here. So I got log of 0.05, and that is going to be equal to log of 1/2 to the n. Alright, not really much I can do right now. Log of 0.05, we can calculate that later, but we're not going to deal with that right at this moment. Now, log to the 1/2 n, we can bring that n up top down to the bottom, so that n will come out front, and then we have this log 1/2. This allows me to solve for the number of half-lives. So the number of half-lives is going to be log of 0.05 divided by log of 1/2. So what this is going to tell me is how many half-lives have occurred while this has all gone on. So let's see what we got here. So this is going to give me about 4.3219 . So what it's saying is that we have a half-life of 121 days. So for 95% of the sample to decay, it's going to have to have gone through about 4.2319 half-lives, so a little over 4 half-lives. So if we know that n is t over t half, the time this is going to take is the number of half-lives multiplied by the half-life. So we have that 4.3219 half-lives, and then the half-life we're told is 121.2 days. So the last step, we're going to multiply by that 121.2. So what we're going to get is we're going to be about 523.8 days. So what this tells us is that based on tungsten 181 having a half-life of 121.2 days, if you want 95% of that sample to decay or only want 5% of it remaining, it's going to take you 523.8 days for that to happen.